Alexander Fleming and his penicillin, the first effective treatment against infection. Imagine a world before the widespread availability of antibiotics, a world where a seemingly minor cut could escalate into a life-threatening infection. Until the mid-20th century, humanity lived under the constant shadow of bacterial diseases. Simple infections from everyday injuries, childbirth, or even dental procedures often turned deadly. Pneumonia, tuberculosis, and scarlet fever were major killers, sweeping through communities with devastating effects. Even common ailments like strep throat could lead to serious complications like rheumatic fever, damaging the heart. Hospitals, while offering some relief for injuries, were often breeding grounds for infection themselves. The lack of effective treatments meant that doctors could often only offer supportive care, while the body fought a desperate and frequently losing battle against unseen microbial invaders. Alexander Fleming and penicillin, a triumph overshadowed by neglect and misuse. The history of medicine is punctuated by moments of profound transformation, and few discoveries resonate as deeply as Alexander Fleming's accidental stumble upon penicillin. Before this pivotal moment, the world was a far more perilous place, where unseen microbial enemies held sway over human health. Infections, whether stemming from a minor scrape, a surgical procedure, or a systemic disease, were a constant threat, often leading to debilitating illness and premature death. The advent of penicillin in the mid-20th century shattered these grim realities, ushering in the age of antibiotics and forever altering the course of human history. Alexander Fleming, a Scottish bacteriologist at St. Mary's Hospital in London, was not actively searching for a revolutionary drug. In 1928, upon returning from a summer vacation, he noticed a peculiar mold contaminating a petri dish containing Staphylococcus bacteria. Around the mold, later identified as Penicillium notatum, the bacteria had failed to grow. This astute observation sparked Fleming's curiosity, leading him to investigate the mold's properties. He discovered that it produced a substance capable of inhibiting the growth of various harmful bacteria. He named this active substance penicillin. Fleming recognized the immense potential of his discovery. He published his findings in 1929, highlighting penicillin's antibacterial properties and suggesting its possible therapeutic use. However, extracting and purifying penicillin in a stable form proved challenging with the resources available to him. While he conducted some early, limited clinical trials with promising results, large-scale production remained elusive. Herein lies a somewhat disheartening chapter in the story of penicillin. Despite Fleming's groundbreaking work and the evident potential of penicillin to combat deadly infections, the British government and local pharmaceutical companies showed a surprising lack of enthusiasm for large-scale development and production. Perhaps preoccupied with the looming threat of World War II and other pressing concerns, or perhaps due to skepticism surrounding a naturally derived substance, the necessary investment and infrastructure were not prioritized. Across the Atlantic, however, the significance of Fleming's discovery was not lost. As World War II raged, the urgent need for effective treatments for battlefield wounds and infections became starkly apparent. American scientists and pharmaceutical companies, spurred by government support and a keen understanding of penicillin's life-saving potential, poured resources into research and development. By the early 1940s, American companies like Merck, Pfizer, and Squibb had successfully scaled up the production of purified, stable penicillin. This American ingenuity proved crucial in saving countless lives during the war and laid the foundation for the widespread availability of antibiotics in the post-war era, generating significant commercial success for these companies. The story of penicillin serves as a powerful reminder of the transformative impact of scientific discovery. It also highlights the crucial role of investment and industrial capacity in translating laboratory breakthroughs into tangible benefits for humanity. While Fleming's initial discovery was a stroke of scientific brilliance in Britain, it was the vision and enterprise in America that truly unlocked its potential to revolutionize medicine. However, the very success of antibiotics like penicillin has led to a new set of challenges. The widespread and often indiscriminate use of these life-saving drugs has fueled the alarming rise of antibiotic-resistant bacteria. When antibiotics are used unnecessarily for viral infections, or when patients fail to complete the full prescribed course, bacteria are given the opportunity to evolve and develop resistance to the drugs designed to kill them. Stopping antibiotic treatment prematurely, even if symptoms improve, is particularly dangerous. This allows the stronger, more resistant bacteria to survive and multiply, potentially leading to a recurrence of the infection that is far harder to treat. Similarly, Using leftover antibiotics or taking medication prescribed for someone else contributes to the problem by exposing bacteria to sublethal doses, further promoting resistance. The consequences of widespread antibiotic resistance are dire. We risk returning to a pre-antibiotic era where common infections once again become deadly. Multi-drug resistant bacteria are already emerging, posing a significant threat to global health.